Hello everyone, welcome back to Rush Me 3D. I'm James. A couple of weeks ago I looked at the TD-3, a device to measure transmission distance, or TD, of filament. But this wasn't the first device to do it. In fact, the TD-3 was made as an alternative to what I'm looking at today, the TD-1. The TD-1 was created by Ajax 3D, working closely with the developer of HueForge from within the HueForge Discord to create, at the time, the first device of its kind. It was created to provide quicker, easier and more accurate TD values. Before the TD-1, you either had to print a specific model to determine those values, or create a basic device that used a light source behind printed swatches. So this was a big step forward. Before we begin, I'd like to thank Ajax 3D for providing the license for the TD-1 built for this video. I'll talk more about the license and build costs later. So let's take a closer look at the TD-1. So taking a closer look, I'll say that the TD-1 is about twice the height of the TD-3 and only about 5mm larger in length. And they are similar in depth, which I'm okay with. You can also see that we've got a nice dual colour case, which I think looks really nice. And it actually feels quite nice in the hand. It's a good size. We also have the filament that feeds in from the sides and goes through all the way through, allowing the sensors to do their thing. And we have the USB-C port on the back. But it's not just two sensors in the TD-1. Let's take a look at all the components needed to build a TD-1. First thing we have is a TSL2561 luminosity sensor. So this little thing is the thing that actually will give us our transmission distance value. What we also have inside is a TCS3472 RGB sensor, or color sensor, and this is what will display the hex value of the filament that we put into the TD-1. And to control all these things, we have an RP2040 microcontroller. This is basically a Raspberry Pi chip on a very small little circuit board. Another thing that sets this apart from the TD-3 is the fact that we now have a display. So this is a SSD 1306 display. It's 0.96 inch in size. And then the next thing we have that will provide the light source for the TD-1 is two SK6812 RGB NW LEDs, and the NW stands for natural white. So they're all the electrical components, but what we also have is a small push button switch, and this is 6x6 by 4.3 millimeters. And then to activate that switch, we have a 7mm steel ball. Now in this version that I built, all these components are then joined together with this rainbow flat ribbon cable. So you can see that there's a couple of things that sets this apart from the TD-3. The obvious being the screen and the microcontroller being an RP2040 rather than a ESP32. And unlike the TD-3, the TD-1 has a working RGB sensor to give us that color code, and the integration with HueForge, which works really well, which I'll demonstrate now. So I've currently got HueForge running, as you can see. If I plug in the TD-1, this will now boot up and show us that it's ready to insert filament, and we've got this little HF in the corner of the screen. This denotes that it's got a connection to HueForge. So if I just take a sample of filament and insert it into the side, you can see that we're reading a TD value, and we've now got a hex value. And that has automatically opened a window in HueForge where we can basically put in the details of our filament. So this is eSun pink. The color is not necessarily 100% 100% accurate, but it's still pretty good on 90% of the filaments I've used so far. So once that's done, you just click add or save and close. And then this has been added to my own database over here. So yeah, pretty easy. So let's take a look at the build and purchase options of the TD-1. And I'll have links in the description for all the options I'm about to look at. Some are affiliate links and they help support me to continue making videos like this. Let me start with the build option I chose for my TD-1. That being the more involved build, meaning you will require soldering equipment and tools to prepare wires, etc. Now, this is probably the most difficult option as it requires soldering individual wires to each component and then soldering those directly to the RP2040, including merging multiple ground, 3.3 volt, SDA and SCL. Now a wiring diagram is available, and if you choose to use the rainbow ribbon cable from the BOM, you should be fine, but it's worth noting have a solid skill in soldering and a fine tipped iron is beneficial. So I was also going to show you the build process of my TD-1. However, because I chose the more involved option, I wasn't happy with my setup and showing it clearly proved difficult. However, AJ has provided some good guides on their website, which I've linked to in the description. Although one issue I did run into was with the RGB LEDs. I purchased the ones from the BOM, but they arrived with the pads for soldering 90 degrees to those shown in the guide. It meant being extra careful when soldering because of the printed part that holds the LEDs in place, but it all works okay. The next option is the PCB build. This build uses custom PCBs that were previously only available with a kit purchased either from Ajax 3D or a reseller. However, these now are available from Big Tree Tech and BQ. This makes the build easier and you will need a few less parts, but it still requires a soldering iron, but it avoids all those individual wires. The next option is to buy the new TD-1S. This is a partnership between Ajax 3D and Big Tree Tech and BQ. It's a smaller, ready-to-go unit. It's functionally the same as the TD-1, but in a smaller injection molded case. I've purchased a few Big Tree Tech products over the years, and I've always been very happy with them, so I think this is going to be a good quality, ready-to-go option. The last option is what I'll call the bare bones build. After speaking with AJ, they mentioned the possibility to remove some components if the builder wanted to save a little bit of money. This option removes the RGB sensor, the screen, switch and 7mm ball, essentially just leaving the MCU and luminosity sensor. So only TD values are achievable and will require HueForge to see those values. But if you're building a TD-1, you probably already have it and will be using it to store your calculated values, so it's a build worth considering. With those options outlined, let's have a look at the costs involved with each of these options. As you can see, it offers quite a range of costs from the bare bones £18 to the TD-1S at £71. Now, I haven't included things like soldering equipment or printed parts because if you're building one of these, you probably already own the equipment, and printing case is no trouble. You'll also see all but one option requires a license. So now is probably a good time to talk about the license situation. Essentially, to use a TD-1 once built requires you to obtain a license. This is done through Ajax 3D's Patreon page. The way it works is that if you only require one license, you sign up. Once issued your license, you can either drop to a lower price tier or even the free tier. However, remaining in the license tier grants you a new license credit each month, meaning you could build additional TD-1s and sell them with a license. At least that's my understanding of it anyway. Now, something important to note is that your license is tied to the RP2040 in the TD-1, meaning you can't use it multiple times. And also, if your RP2040 become damaged, you might be stuck. However, I'm sure in such a case, emailing AJ would probably resolve the issue. Now personally, I've found having the screen a nice feature, and although the hex color hasn't always been accurate, it's a cool feature to have. And I believe this is able to be calibrated, and the new firmware to be released soon improves upon this further. So having looked at all these options, if you're a maker and enjoy building things like I do, I think the PCB option is the best. It's a good balance between a DIY project and saving costs. But if you're looking for an off-the-shelf, ready-to-go, sleek-looking product, then the extra cost of the TD-1S might be for you. Okay, so now we've had a look at the features of the TD-1, as well as the build and purchase options, I thought it would be helpful to finish off this video by comparing the TD-1 and the TD-3 by taking a look at some of the measurements from each device. I selected 15 PLA filaments from my collection, and each one was tested 3 times on each device. I tried to select a range of colours and types with some matte, silk and glitter filled filaments. Looking at the results from the TD-1, you can see they are very consistent, with a maximum variance of only 0.01 across the 3 samples, but most were 0.003 or less. And here are the results from the TD-3. So we do get a higher variance of 0.044 across the 3 samples, but also overall the samples had a higher variance than the TD-1. To compare them against each other, I've averaged the results of each filament and then found the difference between them from each device. I'm not sure if this is the best way to do it, but this shows the TD-1 measures a higher TD on all filaments apart from the black sample. The difference ranges from 0.15 to 2.44, which is bigger than I expected, but I'm not sure why this is. Maybe the design of the printed parts makes a difference, because I do find the TD-1 is much tighter in the filament channel, meaning the sensor only has light from through the filament rather than around it, which is what I found on the TD-3. Perhaps the TD value is calculated differently between the TD-1 and TD-3. Ultimately, which TD measuring device you choose is your choice, and I hope that this and the previous video has given you some valuable information to help you choose. Personally, I see the benefit of both. I do like the open source nature of the TD-3, but I also find the screen and HuForge integration of the TD-1 an easier device to use. And I think the maturity of the TD-1 firmware shows. But again, both are being actively developed. That's where I think I'll end this video for today. As mentioned, I'll have links in the description for where to get more information on the TD-1, as well as links to purchase options. And I want to say thank you again to AJ from Ajax 3D for the license for the TD-1 used in this video. Thanks to all of you for watching. Please don't forget to leave a like on this video, and if you've enjoyed it, please consider subscribing for future content.